The very first stage is the signal generator, and we are going to be designing a signal generator for our inverter. But before that, we will choose our input voltage. This input voltage will be the total input voltage in which our inverter will operate on. This controls our input voltage. So I'm going to turn on the switch. So we are designing a 24-volt inverter. So we're going to choose at least 26 voltage for a 24-volt inverter. Let's begin our design. The very first thing, we connect the NE55 timer, which will act as our main digital signal generating source. With the manufacturer datasheet, you can learn what each pins of the 55 timer stands for. So therefore, using a jumper wire, I'm going to be linking all the pins accordingly. The very first pin is pin 8 to pin 4, and then the second pin is pin 2 to pin 6. The circuit diagram will be in the group. For those who want to join our group, the circuit diagram will be in the group, and we pay to join the group. Now that we have linked the necessary pins together, we are going to attach an external component that will help the 55 timer work as it is supposed to. The very first external component is to connect a 1K resistor across pin 7 and pin 8. Since pin 8 and pin 4 are linked together, I can use either side. And then the next thing is to introduce a 50k ohm variable resistor or a 50k ohm streamer. I'm going to connect the first pin to pins 6, and then the second pin, the middle pin of the variable resistor, I'm going to connect the middle pin to pin 7. This variable resistor will help us change our frequency of operation. The next part of the circuit is to connect the capacitor, a non-polarized capacitor, across pin 1 and pin 2. Note that pin 1 of the 55 timer is the ground pin, and pin 8 and 4 are the VCC. The reason why I use 4 capacitors of 1000 NF each is to be able to store a frequency below 100 Hz, because the original frequency of a power inverter or any power supply system is between 50 to 60 Hz. So for me to get up to 50 to 60 Hz, I need a more larger capacitor in capacitance. So this will make it 4000 NF. Now the next thing is to connect pin 3, which is the digital output pin of the 55 timer. For us to know that this circuit is working, we need to connect an LED to the output. We need to connect an LED, this is a yellow LED, to the output. You can use any color you wish. And then we use a 1K ohm to step down power to the ground pin of the LED by connecting 1k ohms to ground. This is used as ground and this as VCC. The same thing for this and this. Okay, after connecting our signal generator section, we need to choose the voltage at which the signal generator should operate on. So before we continue, let us pause and understand something about choosing voltage for a logic system in a power inverter circuit. Okay guys, before we continue, I would like us to understand something about choosing the voltage of your logic system in any circuit. When designing any circuit, especially circuit that has to do with power, your logic circuit must always operate at a lower, much more lower voltage than the total voltage of the system. For an example, in this inverter we are designing, our total input voltage is 26 volts, which is otherwise 24 volts. But the logic system must operate at a much more lower voltage than the total input voltage. The reason for this is because if the logic system of the inverter operates at the same input voltage as the entire system, whenever there is a fluctuation in input voltage, it will cause a misbehaving or a malfunctioning of the logic system. With this can cause your inverter to blow up or to always have a malfunctioning kind of behavior at any time. So I hope you understand this aspect. Without wasting much of your time, let's continue the experiments. So in this case, we choose 5 volts for the digital signal generator. To step down the 26 volt to 5 volt, we are going to use a voltage regulator, a transistor which is designed to step down high voltage input up to 32 volts down to 5 volts. This transistor has 3 pins: in, out, and ground pin. The ground pin, which is the middle pin, is used to control the amount of voltage flowing between the input and output pin. And this is 7805, which is used for regulating positive charge. Now I will connect it to the board, and then I'm going to wire the input pin to positive power source. Then I'm going to use a 100 ohms resistor from the middle pin to ground, and then the output pin will go to the positive pin of the 55 timer, or the VCC, which is either pin 8 or pin 4. Okay guys, before we continue, let's check the output voltage of our regulator. Okay, this is 5.2 volts, which means our regulator is working very well. So the next thing is to power up the digital signal generator by connecting the VCC to output pin of the regulator and pin 2 to ground, pin 2 to ground. Now it is oscillating, but it is hard for you to see with your naked eyes because the rate of speed is faster than what we can see as normal human beings. What we need to do is to take off the ceramic capacitors or the non-polarized capacitors and connect an electrolytic capacitor in order to store a much more lower frequency. As you can see, it is oscillating. So our digital signal generator is ready.